So we just finished our Chapter 6 test on polynomials. We're going to set that aside for a bit and move on and talk about our next group of functions called radical functions. And we're going to start here today with some definitions and notation and such. So when we talk about radicals, we have like square roots, cube roots that you guys are probably familiar with, fourth roots, or really in general, we can talk about nth roots. So square roots, cube root, this is like a fourth root. The next one would be the fifth root, and then the sixth root, and the seventh root, and etc. And we call this guy at the very end the nth root. So in this chapter, we're going to be kind of studying how we deal with these radical functions. So what their properties are, how to graph them, how to solve equations involving them, simplify expressions involving them, amongst some other topics. But today we're really just starting with, going to start with a bunch of vocab, and then we're going to deal with some graphing. So the first piece of vocab here is these numbers that are like in the check mark part of our radical. These numbers are called the index. Notice on the square root, we didn't write any number in that little check mark part of the symbol. What number do you suppose goes there that we don't write but we know is there? A 2. Yeah, that's correct. Because it's a square root, so a 2 goes there. Everybody feel okay there with that idea? So those numbers are called the index. And it's how you can tell the difference between these different types of radicals. So the number that's underneath the radical this number is called the radicand. And then when we talk about this n here, there is a restriction on n. So n or when we talk about these n's, they're only positive whole numbers, and they have to be greater than or equal to 2. So 2, 3, 4, 5, 6. These are all things that we'll define as radicals. If it's not a whole number, like a third or something, we're not going to define that as a radical. Or if it's like a weird irrational number, like the square root of 2 inside the index, that's a weird thing. We're not going to define what that means out there in this course. So for our purposes, when we talk about radicals, we're talking about things like square roots, cube roots, fourth roots, fifth roots, etc. You can't have the 3.5th root. We're not going to define what that means in this course. At least not right now. Okay? So we have this operation, square root, cube root, fourth root, etc. And some of these operations we've been using for a long time. But let's kind of write out a formal definition of kind of what this means. So if we say we have the square root of x is equal to a, maybe I won't use x, that's maybe a bad, we'll say b. What does this imply? Well, it says then that a squared would give me b. Let's just kind of see what I mean by that. We all know the square root of 4 is 2 because 2 squared gives us 4. What's up, my dude?
So
everybody see that? So if we were to define the cube root of b equal to a, what would that imply? Is equal to b, right? So, for example, if I had the cube root of 8 is equal to 2, that's because 2 to the third is 8. Everybody okay with that idea? So we can keep doing this for each individual radical, but that's kind of annoying. Let's just do it once in general for the nth root. So what does the nth root of b equal to a imply? A to the n is equal to b. Very good. And again, for n's equal to positive whole numbers greater than or equal to 2. So this is like our general definition. Okay. So we have this new operation, the radical. We've kind of defined what the notation is that we're going to use to represent these radicals and what the different parts of that notation are called. We've defined what it means to take a radical of a number and get an answer back. What we want to do next is we want to talk about when we take the radical of a number, when we get a real number result back and when we don't. I was using these, I guess. So what we're interested here right now is figuring out when the nth root of b is equal to some real number. Well, let's start with square roots. What kind of numbers can we take the square root of? Give me an example. 16. Great. So the square root of 16 gives me a real number result, right? What's another example? 4, because the square root of 4 is 2. That's another real numbered result. Give me one more example. 9. Okay? Now, all three of these examples that you guys gave me were gave me an integer result. Is that always going to be the case? No, right? If I say take the square root of 2, that's going to give me, you know, some big hairy decimal. But it's still a real number. Everybody agree with that? Is there anything I can take the square root of that I don't get a real number back from?
0.
Well, the square root of 0 is still just 0, so that's okay, but you're on the right track.
No. Negative.
Negatives. Yeah. So when we take the square root of a negative, we get imaginary number back. Those are not real numbers. So if we talk about the square root of b is equal to a real number if b is greater than or equal to 0. Right? If you have a positive or positive number or 0, you can take the square root and it's all fine. If it's negative, though, we don't get real number results. Okay. What about now looking at cube roots? Let's look at the next situation. So you saw earlier the cube root of 8 was equal to 2. We gave that as one of our examples just a moment ago. What are some other numbers that we can take cube roots of? $27. So the cube root of 27 is 3. How about 1? What's the cube root of 1? Just 1. Okay. What about the cube root of negative 1? Can we do that?
Yes.
Yes. Recall the definition. So this would imply that negative 1 to the third should give me negative 1. Is that the case? Well, negative 1 to the third is negative 1 times negative 1 times negative 1. If I multiply these two negative 1s together, I get a positive 1. And positive 1 times negative 1 is negative 1. So definitely can take the cube root of negative 1. Can we take the cube root of any negative number? Yeah, the same thing will happen, right? So what does this tell me then? So it says we can take the cube root of any real number, right? Okay. So we've seen sometimes we can take the radical of a negative number, and sometimes we can't, right? In the case of square roots, we can't square root negatives. But in the case of cube roots, we can cube root negatives. It would be nice to predict when that was going to work and when it wasn't. Do you guys have any intuition as to when we can take the square roots? Or, I'm sorry, take the radical of a negative and when we cannot?
No.
So if you think about square root and we think about cube roots, what's going on there? What do we think? You need to get a more balanced diet or something here, Holmes. Getting all these leg cramps.
Supposed to be stretching enough to hear that before Mike Tyson. What?
No.
Last thousand prejudice. President Reagan.
Oh.
You never heard that?
I just know about fading into Bolivia.
How do you get cock cramps? Bananas and pickle juice? Is that it? Yeah.
I think in general having a more balanced diet and then
Like,
water is really important.
I usually drink some water. I usually drink like 20 bottles a day. Like these? Yeah. 8, 3 or 4 usually, like drinking 4 a day.
You should probably
Now I
do.
drink more.
Are you also working out?
Yeah.
Should probably be like 3 or 4 times that amount.
Oh, yeah.
Like if you don't have to go to the bathroom like every 20 minutes, you're probably not drinking enough.
Okay. Yeah, I'm definitely not drinking.
I think that's probably contributing a little bit to what's going on.
Yeah. We'll keep it name. Bacteria. I don't know. They have. I think they do that apples. A lot of them have it.
So we saw for square roots, what index does a square root have? 2. We can't deal with negatives, right? For a cube root, what index does a cube root have? 3. We can deal with negatives. What kind of number is 2? Yeah. So again, if b is a negative number, if we're taking an even root, that doesn't work. If it's an odd root, though, no problems. That's the big takeaway there. Is everybody okay with that idea? Okay. And that's an important observation. We'll use that here in a few minutes to justify a bunch of things. But that's an important observation, right? So that's something you definitely need to remember. That even roots, we have to be careful about what we're taking the even root of, specifically when it comes to negatives. But odd roots, we can apply all willy-nilly. It doesn't matter what you take the odd root of. It'll work. Okay? So let's move on and start talking about graphing now that we've talked a bit about what a radical is, what the definition is, what are some kind of properties of them. Let's talk about graphing. So the general equation for a square root function is a times the square root of x minus h plus k. And for a cube root function, it's the same thing, but we're going to have a cube root there instead of a square root. It's a bit messy. So better. Okay. Notice that we're using the letters A, H, and K to describe these parameters in this equation. We've used these letters before, and in fact, this is a situation where these 3 letters are going to describe transformations. Do you recall what transformations the coefficient of A is going to give us? This was something we did in first semester. It's not a translation. It's It's a dilation is one of them, yes, and the other one is the other R1. Reflection. Okay. That is a type of transformation, but it's not one that we look at in this course. Yeah, we need trigonometry to be able to deal with the rotationals. So we don't deal with that in this course. But it is a type of transformation. You're not wrong there. Okay? Okay, so for A, negative, that's going to give us our reflection across the x-axis. And then the magnitude of A gives us our dilations. So if the A is greater than 1, or the absolute value of A, I should say, is greater than 1, that's going to give me a vertical stretch. And if the absolute value of A is less than 1, that'll give me a vertical shrink. Is this looking familiar here?
Yes.
These were things I think I asked you to memorize in first semester. Hopefully you still kind of have them rattling around back there because they're going to come up again in the next several units. What does the H do? Do you remember that? What transformation does the H do? That's the translation, left and right. That's good. So when H is positive, we're going to go right that many units. And when H is negative, we're going to go left that many units. And then what does the K do? That's also a translation. It's in the other direction though, so it's up and down. So when K is positive, we'll go up that much. And when K is negative, we'll go down that much. If K is 0, what happens? Doesn't move. If H is 0, what happens? Doesn't move. If A is 1, what happens? Nothing happens, right? Can A be 0?
No.
No, right? If A was 0, you just have K left, right? So A can't be 0, just FYI. So for example then, let's say we have, let's do that. Y equals negative 2 times the square root of x minus 3 minus 1. Let's evaluate or identify, our values for A, H, and K. What's our value for A? Negative 2. What's our value for H? What is the value for H?
Oh, 3.
Positive 3. Remember that the H's are always the opposite sign of whatever they appear in the function. And the value for K is negative 1. Okay. So now let's identify what the A does. Since A is negative, we're going to have a reflection across the x-axis. And because the absolute value of A is greater than 1, we'll also have a vertical stretch. Everybody okay there? Just using the criteria that we just wrote down a moment ago. Now let's look at the H. Because H is positive, we're going to go right 3 units. And because K is negative, we're going to go down 1 unit. Does everybody feel okay with this? As just a refresher, right? We did this a bunch first semester, and we're going to do it a bunch here more this semester, but it doesn't hurt to kind of go through it and walk through it again rather closely. Okay? All right. So I want to go back and look at these two general form equations again for a moment. So our goal when graphing is to get only rational numbers to plot. That is, we don't want any irrational numbers. An irrational number is just something that can't be written as a fraction. So what are some examples of irrationals? So irrationals are still real numbers, but they can't be written as a fraction. So how about like square root of 2 is an example of an irrational number? Is it going to be easy to get irrational numbers when we're trying to graph these radical functions? Yeah, so we have to be a little bit careful about how we're choosing our x's so that we don't get any irrational numbers, okay? So if we're talking about the square root function, what I'm going to be interested in are numbers that I can take the square root of and give me a whole number back. So what's the smallest number that I can take the square root of and I get a whole number from? Well, 4 is one of them. It's not the smallest, though. 1 is one of them. It's not the smallest, though. Can't take the square root of a negative. 0 is the smallest one. Okay. What's the next one after 4? After 4? 9. Yep. And then after 9 is? 16. So these, what my goal is going to be then, is I want my x minus h to turn into 0, 1, 4, 9, and 16. So let's start with the x. What number, or what should I pick x to be for x minus h to give me 0? H is whatever h is.
I'm actually curious. I don't know.
I think you know the answer. You're just like the abstractness is what's bothering you. So if h is 2, what would you pick?
H is 6. 6, right? Or no?
If I want x minus h to be 0, if h is 2, what would I pick for x? 2. If h is 3, what would I pick for x? No, I'm trying to get 0.
Oh.
Every time.
Oh.
3.
What did you say? 6? H was 6 or H was 3?
I said 3. Okay. You must have heard 6.
3.
Okay. If h is 7, I'd pick 7. So if h is h, I'd pick h. Okay. So that's the first value for x I'm going to pick. It's just whatever the h is. Right? Now suppose I want to get 1. What would I pick?
H plus 1.
H plus 1. If I want 4, what would I pick? H plus 4. And 9, I'll pick H plus 9. And for 16, we'll pick H plus 16. Everybody okay with that? Now the y values we get also from this. I'll write it this way. where do you suppose these 0, 1, 2, 3, 4 are coming from? They're the square roots of 0, the square root of 1, the square root of 2, the square root of 3, and the square root of 4. Okay, so this is going to be my general rule for how I'm going to choose my square root, or how I'm going to choose the points to graph a square root function. So this is very important. You definitely want to have this table written down, because this is going to be the rule that I'm going to use when I'm doing my graphing of square root functions. So let's say we want to graph y equals 2 times the square root of x plus 1 minus 3. First thing I'd want to do is write down my values for a, h, and k. What's my value for a? 2. What's my value for h? -1. And what's my value for k? -3. So now I'm going to make my XY table using that set of rules from above. So the first value I should pick for x is h, which in our case is -1. The second value I should pick for x is h plus 1. And then I'll have h plus 4. And then h plus 9, and then h plus 16. And the y-coordinates are going to be 0 times a plus k, but since k is a negative, I'm just going to write minus instead of plus a negative. Is everybody okay with me doing that? So 1 times a plus k, 2 times a plus k, 3 times a plus k, and 4 times a plus k. Oops. Forgot the plus sign there. Jeepers creepers. Sorry about that, guys. Is everybody okay with how I filled this table out? So now I'm just going to evaluate all these little problems. So I get 0, 3, 8, and 15. I get -3, -1, +1, +3, and then +5. Is everybody okay there, Matthias? So h comes from in here. So h is going to be the opposite sign of whatever that number is that's being added or subtracted to the x.
So that was x minus 1.
Correct. Are we good with how I've found the points for my table? Now we need to plot our points. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 1, 2, 3, 1, 2, 3, 4, 5. So I have -1, -3, 0, -1, 3, +1, 8, +3, and then 15, +5. Now I need to draw this line to connect my points. Before I do that, though, I want to ask you guys a question. How am I going to draw this line? I mean, obviously it's got to go through all these points, but should it have arrows at one end, both ends, neither end? Well, let's think back. The answer we addressed earlier in the lesson. Can I take the square root of any number? I can't get a real number though, right? So I have to be careful, right? This arrow is only going to go one direction because the other direction is going to be towards numbers I can't take the square root of. Okay? So which direction should my arrow be going? To the left or to the right? To the right. So when I draw my graph, I need to make sure that I have my arrow going only in one direction towards the numbers that we can take the square root of. Now I'm going to be very picky about how you've drawn your line here. Let's say hypothetically, if I'm looking at that very first point, you draw and it looks like this. You see that part that's hanging over? If I see that, I'm going to mark it down. Okay, that's incorrect because there are no values of x before -1 that if I plug into this function, I can take the square root of. So I'm going to be picky about that. I just want to let you guys know right away that that matters to me a lot when I'm looking at your pictures. So it needs to be relatively neat. I also need to see the arrow at the other end. If your graph stops at the last point that you've plotted and doesn't continue with an arrow at the end, mark that down. Those are the two things I'm looking for because we have to be very clear here because our graph does not extend in both directions. It does not stop in one direction or the other. Okay, you need to make it clear to me that you understand what's going on there. Is everybody okay with that? Okay. There's one last thing we want to talk about when we graph one of these square root functions, and that's the domain and range. So, if I look at my graph, does my graph have a beginning, a furthest left point? It does, right? So I know I'm going to have a bracket to start my domain. And that furthest left point is always going to be my h. Is there a point furthest to the right? No. So what do we have at the end then? The positive infinity. Everybody's okay there. Now the range, we could have two different situations depending on whether our a is positive or our a is negative. If our a is positive, notice we have a lowest point. So we'll have a bracket, and that lowest point will always be k, up to positive infinity. If the a is negative, this would be reflected. So there would be no lowest point, but the highest point would be at k. So for this specific problem, what would we say our domain is? So for our specific example, what would we say the domain is? -1 with a bracket to positive infinity. And what would we say the range is? -3 with a bracket to positive infinity. So these two rules here, also very important. You want to make sure you have those written down. That's going to be how we'll find the range for these square root functions. Okay? Now let's talk about the cube root function. Just as an aside, how do I tell the difference between a cube root and a square root function when I look at them? Yeah, I look at the index, right? The index is going to be different. Cube roots have a 3. Square roots are usually blank, right? Okay. So just like we did for square roots, I'm going to be particularly interested in, for a cube root, numbers that we can take the cube root of and get a whole number back. However, because we can cube root negatives, there is no smallest number we can take the cube root of. So what I want here is the 5 numbers I want are the 5 numbers that I can take the cube root of that are closest to 0. So one of those is obviously 0, right? Because when you take the cube root of 0, we established that earlier. What's the next number after 0 that we can take the cube root of and get a whole number back? There's 1 in between. 1, but 8 also works. What's the first number preceding 0 we can take the cube root of and get a whole number back? -1. And the number before -1? -8. Everybody's okay there? So just like before, when we make our XY table, we're going to have -8 plus h, -1 plus h, 0 plus h, or just h, 1 plus h, and then 8 plus h. Everybody's okay there? And then our y coordinates are going to be -2a plus h, -1a, I'm sorry, I meant plus k, 0a plus k, or just really k, 1a plus k, and then 2a plus k. Where are these numbers -2, -1, 0, 1, and 2 coming from? Yeah, they're the cube roots of these 5 numbers, right? So very similar table as for square roots, but decidedly different, right? You can't screw those 2 up. You have to make sure you're using the right table to make your points. But you'll definitely want that written down. That's an important table. You'll use that to graph all of your cube root problems in the homework. So let's do that. So let's say we want to graph y equals -3 times the cube root of x minus 1 minus 2. So just like before, I'll start by identifying my values for a, h, and k. My value for a is it's -3. My value for h is +1, and my value for k is -2. Okay, I'm going to use my table that we just made now to find my x and y coordinates. So my x's are going to be -8 plus 1, -1 plus 1, 0 plus 1, or just, actually I'll just write 1 there. 1 plus 1, and then 8 plus 1. And then the y coordinates are going to be -2 times -3. And then rather than writing plus a -2, I'm just going to write the subtraction. Then I have -1 times a plus k. Really just k on the next spot. Then I have 1 times a plus k. and 2 times a plus k. And then if I just evaluate these little expressions, I get negative 7, 0, 1, 2, and 9. And then I get 6 minus 4, or 2 is 4. And then 3 minus 2 is 1. Negative 2. Negative 3 minus 2 is negative 5. And then negative 6 minus 2 is negative 8. Okay. So we'll go and graph this now. See, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So I have negative 7 and positive 4. I have 0 and positive 1. 1 and negative 2. I have 2 and negative 5. Then I have 9 and negative 8. Okay. So how should I connect these points? Is my graph going to have arrows at one end, both ends, or no ends? Both ends. Why both ends this time? Because it's a cube root, and we can take the cube root of any number we want and get a real number back, right? So the cube root graphs should have arrows at both ends. So our graph is going to look like this. Again, will I be picky that you've drawn arrows at both ends and both your lines extend past your last point? Yes. Because of the nature of these two graphs and how different they are, I really need you to make sure you're indicating the differences carefully when you're drawing your pictures. The last thing we need to talk about when we talk about graphing cube root functions is their domains and ranges. So if we think about a cube root function, can I cube root any number? Yes, right? So what does that mean the domain is going to be? Yeah, it's going to be negative infinity to positive infinity. For every single time, for all cube root functions, it's going to be that same thing. So remind me this, if I cube root a negative number, what kind of number do I get back? Another negative, right? If I cube root a positive number, what kind of number do I get back? Positive. And since I can cube root any negative, I can get any negative back. And because I can cube root any positive, I can get any positive number back. So guess what the range is? Also, all real numbers. Every single time. That should be easy. Please don't mess this up when it comes to the test and forget this. Because for cube roots, the domain and range are always all real numbers every single time for all cube root functions. Let's stop here today.